Look up at the night sky. The moon, once a beacon of romance and inspiration, now looms as a harbinger of catastrophe. What if the celestial body that has lit up our nights and shaped our tides was no longer a steady guardian, but a force of destruction, hurtling toward us with unstoppable momentum? This isn't a tale of fiction. It's the ultimate doomsday scenario unfolding in real time. For centuries, humanity has gazed at the moon, navigating by its glow, marking time by its phases, and marveling at its beauty. But now, its gravitational grip on Earth is tightening. The tides are swelling, the ground is trembling, and chaos is only beginning. Over the next hour, we will unravel the terrifying chain of events that led us here. We'll explore the devastation, the desperate scientific efforts to prevent the inevitable, and the ultimate fate of our planet. Will we find a way to avert total annihilation? Or are we merely counting down the final days of human civilization? Hold on tight, because time is running out. T. 365 days. The beginning of the end. It's been 150 days since the moon entered a collision course with Earth. What was once a familiar sight in the night sky has now become a symbol of impending doom. The effects are already catastrophic. Ocean tides swell to unprecedented levels, swallowing entire coastal cities. Towering waves crash through streets, buildings crumble, and millions flee in desperation. Earthquakes ripple across continents, rupturing highways and toppling infrastructure. But this is just the tip of the iceberg. How did we get here? To understand, we must rewind the clock, 1 year before impact. At this moment, the moon is still 384,000 kilometers, 239,000 miles away. That distance may seem vast, but in cosmic terms, it's closing in at an alarming rate. To put it in perspective, the space between Earth and the moon could fit every planet in our solar system. But none of that matters anymore. The moon is coming straight for us. For now, life continues, oblivious to the disaster brewing above. The waves seem slightly more aggressive, creeping up shorelines with an unspoken menace. But few take notice. The moon is more than just a glowing satellite. It is a stabilizing force, governing our tides, seasons, and even Earth's axial tilt. Without it, chaos would reign. But why doesn't the moon simply fall to Earth? The answer lies in gravity. The moon orbits Earth at over 1 kilometer per second, 2,300 miles per hour, maintaining a delicate balance. This precise motion prevents it from careening into deep space or crashing down on us. But what if something disturbed this balance? As the moon inches closer, everything we take for granted will change. Seasons will become erratic. Frigid winters will grip the deserts, while the Arctic bakes under scorching heat. Ocean tides will transform into relentless tsunamis, swallowing land masses whole. And this, unfortunately, is only the beginning of our nightmare. T por T. T, 300 days. Rising tides and vanishing cities. The moon has now moved to 250,000 kilometers, 155,000 miles away, and its gravitational grip on Earth is tightening. What was once a gentle influence on our tides has become a force of destruction. The oceans respond violently. Tides surge up to 5 meters, 16 feet, higher than normal, swallowing vast stretches of coastline. Major cities like New York, London, and Miami are in chaos, with millions evacuating in desperation. Roads vanish beneath the water. Skyscrapers stand half-submerged, and entire neighborhoods disappear beneath the relentless waves. The devastation extends beyond human settlements. Marine life faces unprecedented upheaval. Nesting grounds for sea turtles and seabirds like pelicans are vanishing. Fish populations are thrown into disarray as changing ocean currents disrupt ecosystems. Salt water infiltrates freshwater supplies, poisoning reservoirs, lakes, and farmlands. Farmers watch helplessly as crops wither, and clean drinking water becomes an increasingly scarce resource. But this is just the beginning. Has something like this happened before? Scientists believe that 4.5 billion years ago, a Mars-sized object known as Theia collided with Earth, leading to the formation of the Moon. This cataclysmic impact reshaped our planet forever. The remnants of that ancient collision are still visible today, locked in the Moon's very foundation. Now, as the Moon moves closer, we are witnessing another planetary-scale event, one that may rival the very catastrophe that gave birth to our celestial companion. This time, however, the consequences may not forge a new world, but rather end the one we have built. T. 200 days, the tides become tsunamis. The Moon is now just 100,000 kilometers, 62,000 miles away, and its grip on Earth is devastating. Tides, now surging up to 30 meters, 100 feet, engulf entire coastal cities. New York, Tokyo, and Sydney are reduced to half-submerged ruins. Millions who once lived near the ocean have fled inland, desperately seeking safety. Those who remain are left to battle relentless waves, now stretching miles beyond their usual boundaries. But water is not the only enemy. The Moon's gravitational force is distorting Earth's crust, triggering powerful earthquakes. Cities not already swallowed by the rising tides begin to crumble from the tremors. The San Andreas Fault ruptures, splitting California in ways scientists had only theorized. The Himalayas experience violent shifts, sending avalanches cascading into once thriving villages. The world is breaking apart. Beneath the surface, pressure builds. Dormant volcanoes awaken, spewing molten rock and ash into the skies. The Ring of Fire, the most seismically active region on the planet, erupts with unparalleled fury. From Japan to South America, the Earth shakes and burns. Entire regions vanish under volcanic clouds, suffocating life in darkness. Survivors are faced with impossible choices. Inland cities, once considered safe, are now threatened by the looming effects of atmospheric ash and fractured tectonic plates. Crops wither in toxic rain. Infrastructure collapses. The world is entering a new geological age, one shaped not by human hands, but by the violent force of a celestial reckoning. T. 0 days, the Roche limit, and the end of the Moon. The Moon is now just 18,000 kilometers, 11,000 miles from Earth, breaching the Roche limit, the threshold where Earth's gravity overcomes the Moon's structural integrity. This marks the point of no return. Instead of an earth-shattering collision, the Moon succumbs to the immense tidal forces tearing it apart. A monstrous fracture splits across its surface, growing wider with each passing moment. Chunks of lunar rock, ranging in size from small meteors to entire mountains, break free and spiral toward Earth. A relentless meteor bombardment begins. At first, they strike sporadically, fiery streaks illuminating the night sky, a spectacle reminiscent of shooting stars. But as the Moon crumbles further, the impacts intensify. Massive chunks rain down, striking the oceans and continents alike, igniting wildfires, flattening cities, and leaving behind colossal craters. Unlike the asteroid that wiped out the dinosaurs, this onslaught does not end. It only worsens as more debris enters Earth's atmosphere. But the most profound consequence is not the destruction below, but what lingers above. The remnants of the Moon coalesce into a dense ring system, encircling Earth like Saturn's frozen bands. This new ring blots out the sky, casting the planet into an eerie, perpetual twilight. Without direct sunlight, photosynthesis grinds to a halt. Crops wither, forests decay, and oxygen levels begin to drop. As the days stretch into months, Earth's climate spirals into chaos. The absence of solar warmth plunges the planet into an ice age. Snowfall blankets the equator, and once thriving cities are entombed beneath glaciers. Those who manage to survive must do so in the harshest conditions humankind has ever faced. The underground bunkers that once seemed like a lifeline now serve as icy tombs as food supplies dwindle and fresh air becomes a luxury. Even if humanity somehow adapts, the ring system above remains an ever-present threat. Countless fragments continue to spiral toward Earth, striking randomly and without warning. Communication satellites have long since been obliterated, rendering technology useless. The world is silent, disconnected, and suffocating under the weight of its own ruined sky. For those who survive, the question is no longer how to stop the Moon. It is whether life on Earth can ever recover from its downfall. Aftermath. The fate of humanity. If any humans survive, they will awaken to a world that is barely recognizable. The sky, once blue and bright, remains shrouded in a thick veil of dust and debris. The sun's light struggles to pierce through the atmospheric haze, casting an eternal dusk upon the land. The air is colder, the winds harsher, and the land scarred beyond recognition. Civilization, as it once stood, has collapsed under the weight of cosmic destruction. With agricultural systems ruined and clean water scarce, the last remaining survivors face an insurmountable struggle. Once thriving cities are now ghostly wastelands, their towering buildings reduced to skeletal ruins. The remnants of technology lie scattered like relics of a forgotten era. Without satellites, electricity grids, or global communication networks, humanity is forced into a new dark age. One where survival is dictated by the ability to adapt rather than by innovation. Could we have stopped this catastrophe? In theory, perhaps. NASA's Double Asteroid Redirection Test, DART, successfully altered the trajectory of a small asteroid. But the Moon was far too massive, its approach far too swift for any known technology to alter its course. This disaster unfolded at a pace beyond human capability, leaving scientists and leaders powerless to intervene. The question that lingers is not just whether we could have prevented this fate, but whether humanity can rise from its ashes. Could civilization rebuild itself from the ruins, forging a new way of life under an altered sky? Would we find a way to reignite the flames of progress? Or would Earth become a lifeless wasteland, haunted by the echoes of what it once was? One thing is certain: if humanity is to survive, it will not be the same species that once ruled the planet. The world has changed, and so must we. In reality, this scenario will never happen. The Moon is actually moving away from Earth at a rate of 3.8 centimeters per year. For billions of years, it has been locked in a stable orbit. maintaining the delicate balance that allows life to thrive on our planet. The idea of the moon suddenly changing course and hurtling toward Earth is purely the realm of science fiction, at least for now. But while we may be safe from our lunar companion, the universe remains unpredictable. Space is filled with hidden dangers, asteroids, rogue planets, supernovae, and even the long-term instability of celestial bodies. The cosmos operates on a scale far beyond human lifetimes, meaning that while the moon may never threaten us, other forces might. What if, instead of the moon, Mars began drifting toward us? Or if a wandering rogue planet passed too close, disturbing Earth's orbit in ways we cannot yet imagine? One thing is certain: the more we explore, the more we realize how little we truly know. The universe is vast, mysterious, and full of surprises, both wondrous and terrifying. Until the next cosmic question arises, stay curious, stay vigilant, and keep looking up. Thank you for joining us on this journey through an apocalyptic scenario that will never be. But that reminds us just how fragile and extraordinary our existence truly is. But before we leave you, let's take a moment to look beyond the disaster and into the real, fascinating mysteries of the moon. The moon, Earth's closest celestial neighbor, has fascinated humanity for millennia. From ancient myths to scientific discoveries, it has been a constant source of curiosity. Yet, despite the countless missions and advancements in technology, the moon continues to harbor mysteries. Some of its phenomena remain unexplained, challenging our understanding of planetary science and leaving us with questions that demand answers. This section delves into some of the most puzzling and captivating phenomena observed on the moon. One of the most enigmatic phenomena associated with the moon is the occurrence of transient lunar phenomena, TLP. These are short-lived flashes, glows, or color changes on the lunar surface that have been reported for centuries. First documented by astronomers in the 1700s, TLP events remain a subject of debate and intrigue. They can appear as sudden bursts of light, glowing patches, or even areas that seem to darken temporarily. The causes of TLP are still unknown, but scientists have proposed several theories. One possibility is that these phenomena are caused by outgassing, where volatile gases trapped beneath the moon's surface are released through fissures, creating visible changes. Another hypothesis suggests that TLP may result from meteorite impacts, which could produce brief flashes of light as they strike the lunar surface. Alternatively, interactions between the moon's surface and charged particles from the solar wind might also contribute to these occurrences. Despite numerous observations, TLP remains elusive. With advancements in lunar observation technology, including orbiters and high-resolution telescopes, scientists hope to capture definitive evidence of these events. If confirmed, studying TLP could provide insights into the moon's geological activity and its interaction with the space environment. The far side of the moon, often referred to as the dark side, is another area shrouded in mystery. While it is not actually dark, receiving the same amount of sunlight as the near side, it remains hidden from Earth due to tidal locking. This constant orientation has made the far side an intriguing yet challenging target for exploration. One of the most significant discoveries about the far side is the South Pole Aitken Basin, the largest known impact crater in the solar system. Stretching over 1,600 miles in diameter and reaching depths of up to 8 miles, this basin is a geological marvel. However, recent studies using data from the Lunar Reconnaissance Orbiter and China's Chang'e 4 mission have revealed an unexpected anomaly beneath this basin. A massive, dense structure buried under the surface. This anomaly, often referred to as a metallic mass, is thought to weigh billions of tons. Scientists hypothesize that it could be remnants of the asteroid that created the basin, or perhaps material from the Moon's mantle brought up during the impact. Another theory suggests that the mass might be a concentration of metal oxides formed during the Moon's early cooling period. Regardless of its origin, the anomaly raises fascinating questions about the Moon's formation and evolution. Unlike Earth, the Moon lacks a global magnetic field. However, localized magnetic anomalies have been detected on its surface, baffling scientists. These regions, known as lunar swirls, appear as bright, sinuous patterns on the Moon's surface. Some of the most notable examples include the Reiner Gamma swirl and similar formations in Mare Ingeni and Mare Marginis. What makes these swirls particularly intriguing is their strong association with localized magnetic fields. Lunar swirls are often found in areas where the surface is shielded from solar wind particles, suggesting that the magnetic fields may be deflecting the solar wind and preserving the brightness of the terrain. However, the origin of these magnetic anomalies remains uncertain. One theory posits that they could be remnants of ancient magnetic fields generated during the Moon's early history. Another suggests that they may have been caused by cometary impacts, which could have deposited magnetic material on the surface. Studying these anomalies offers a unique opportunity to explore the Moon's ancient past and understand how magnetic fields evolve on planetary bodies. It also has practical implications for future lunar missions, as localized magnetic fields could affect navigation and equipment operation. The discovery of water ice on the Moon has been one of the most groundbreaking findings in recent decades. Using data from missions like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, scientists have identified significant deposits of water ice in permanently shadowed craters near the Moon's poles. These regions, shielded from sunlight for billions of years, create conditions where ice can remain stable. While the presence of water ice is a remarkable discovery, its origin remains a mystery. One possibility is that the ice was delivered by comets and asteroids during impacts. Another theory suggests that water molecules could form through chemical reactions between solar wind particles and oxygen-bearing minerals on the Moon's surface. Understanding how this ice formed and how it is distributed is critical for future lunar exploration, as it could serve as a resource for drinking water, oxygen production, and rocket fuel. The exploration of these shadowed regions poses significant challenges due to their extreme cold and lack of sunlight. However, upcoming missions like NASA's VIPER rover aim to map these ice deposits in greater detail, unlocking the potential for sustained human presence on the Moon. The Moon has also been the site of unexplained signals and observations that continue to spark curiosity. For example, during the Apollo missions, astronauts reported strange flashes of light when their eyes were closed. Known as cosmic ray flashes, these events are thought to be caused by high-energy particles striking the retina. While not unique to the Moon, these flashes highlight the challenges of operating in an environment with intense cosmic radiation. Another curious observation involves the so-called moonquakes. Unlike earthquakes, which are caused by tectonic activity. Moonquakes are believed to result from various factors, including thermal expansion, meteorite impacts, and gravitational interactions with Earth. Some moonquakes occur at depths of several hundred kilometers, raising questions about the Moon's internal structure and whether it still retains some level of geological activity. Additionally, some radio signals detected near the Moon have sparked debates about their origin. While most can be attributed to natural sources, such as solar emissions or interactions between the solar wind and the lunar surface, a small number remain unexplained. These anomalies continue to intrigue scientists and fuel speculation about the Moon's unexplored mysteries. The Moon's phenomena are not just curiosities. They hold the key to understanding broader questions about the solar system's history. Its surface serves as a natural archive, preserving evidence of cosmic events that have shaped the inner planets. Craters, for instance, reveal patterns of asteroid and comet impacts, while isotopic analysis of lunar rocks offers clues about the early solar system's composition. Unraveling the Moon's mysteries also has implications for future exploration. Understanding the processes behind TLP, magnetic anomalies, and water ice formation could inform missions to other celestial bodies, such as Mars or Europa. Moreover, studying the Moon's geology and environment helps refine the technologies needed for long-duration space travel and habitation. The unexplained phenomena on the Moon remind us that even our closest neighbor in space holds countless secrets. Each discovery, from transient flashes to buried metallic masses, expands our understanding of not just the Moon, but the fundamental processes shaping the universe. These mysteries challenge us to look deeper, think critically, and push the boundaries of exploration. As humanity prepares to return to the Moon with missions like Artemis, the opportunity to investigate these phenomena in greater detail is within reach. The Moon, a silent witness to the cosmos, continues to beckon us to explore, discover, and dream. The Moon has always been a source of wonder, but its enigmatic nature has also posed scientific challenges that continue to inspire inquiry. Over the decades, countless theories have emerged to explain the mysteries of the Moon, from its origin to its unique phenomena. These theories not only attempt to answer lingering questions about our nearest celestial neighbor, but also broaden our understanding of planetary science and the early history of the solar system. The most widely accepted explanation for the Moon's formation is the giant impact hypothesis. This theory suggests that approximately 4.5 billion years ago, a Mars-sized protoplanet called Theia collided with the young Earth. The catastrophic impact ejected a massive amount of material into orbit, which eventually coalesced to form the Moon. This hypothesis explains many of the Moon's characteristics, including its size, density, and composition, which closely resemble Earth's mantle. However, recent isotopic analyses of lunar rocks have complicated this narrative. These studies reveal that the Moon and Earth share nearly identical isotopic signatures, suggesting that their material came from the same source. If Theia contributed significantly to the Moon's formation, why don't we see a distinct isotopic difference? This conundrum has led to alternative theories, such as a high-energy collision that vaporized Theia and Earth's outer layers, mixing their materials before forming the Moon. Another theory posits that the Moon might have formed from a series of smaller impacts rather than a single cataclysmic event. This multiple impact hypothesis offers an intriguing perspective on how celestial collisions shaped the early solar system, but it remains less widely supported than the giant impact hypothesis. One of the Moon's most perplexing mysteries is the presence of magnetic anomalies. Unlike Earth, which has a global magnetic field generated by its liquid outer core, the Moon's magnetic field is localized and patchy. These regions, known as lunar swirls, appear as bright, sinuous patterns on the surface, with the Reiner Gamma Formation being one of the most notable examples. Theories about these magnetic anomalies vary. One hypothesis suggests that they are remnants of an ancient lunar dynamo, a mechanism similar to Earth's core that generated a magnetic field in the Moon's early history. As the Moon cooled and its core solidified, this dynamo ceased, leaving behind localized fields in areas where magnetic materials were concentrated. Another theory links lunar swirls to cometary impacts. Comets, rich in volatile materials, could have deposited magnetic particles on the surface during high-velocity collisions, creating the swirls we see today. These features' alignment with magnetic anomalies suggests a strong relationship between the surface's appearance and its magnetic properties, but the exact mechanisms remain unclear. Understanding these anomalies not only sheds light on the Moon's magnetic history, but also provides a window into the processes that govern planetary magnetism. Future missions equipped with advanced magnetometers could help unravel the origins of these intriguing patterns. The discovery of water ice in permanently shadowed craters near the lunar poles has revolutionized our understanding of the Moon. This ice is thought to have been preserved for billions of years in regions that never receive sunlight, where temperatures can plunge to minus 250 degrees Fahrenheit. However, the origins of this ice remain a subject of debate. One theory suggests that the ice was delivered by comets and asteroids, which deposited water molecules during impacts. Another hypothesis posits that solar wind particles interacting with oxygen-rich minerals on the lunar surface could have produced water through chemical reactions. This process, while less efficient, could explain the presence of ice in regions not directly impacted by comets or asteroids. The distribution of water ice also raises questions. Why is it more concentrated in some craters than others? Is the ice mixed with regolith, or does it exist in pure layers? Missions like NASA's VIPER rover aim to answer these questions by mapping and analyzing the ice deposits, which could serve as critical resources for future lunar colonies. Transient lunar phenomena, TLP, are one of the Moon's most enduring enigmas. These fleeting events, which include sudden flashes of light, glowing patches, or temporary darkening of the surface, have been reported for centuries. Despite numerous accounts, TLP remains elusive and poorly understood. One plausible explanation for TLP is outgassing, where volatile gases trapped beneath the surface are released through cracks or fissures. This release could produce visible effects, particularly in areas with concentrated geological activity. Another possibility is that TLP results from meteorite impacts, which create brief, intense flashes upon striking the lunar surface. A more speculative theory involves electrostatic activity. The Moon's lack of atmosphere allows the solar wind to directly interact with the surface, potentially creating localized electric discharges that manifest as TLP. Observing these phenomena in real time is challenging, but advances in telescopic and orbital imaging may soon provide clearer evidence. While the Moon is often considered geologically dead, the existence of moonquakes suggests otherwise. These seismic events, detected by instruments left behind during the Apollo missions, occur in several forms: thermal, impact-related, and deep moonquakes originating hundreds of kilometers below the surface. Deep moonquakes are particularly intriguing because they imply the presence of residual geological activity. Some scientists theorize that tidal forces from Earth's gravitational pull create stresses within the Moon, triggering these quakes. Others suggest that slow cooling and contraction of the moon's interior may also play a role. The implications of moonquakes extend beyond academic curiosity. Understanding their causes and frequency is essential for designing lunar habitats and infrastructure capable of withstanding seismic events. Future missions with advanced seismometers could refine our understanding of the moon's internal structure and its ongoing evolution. The discovery of a massive, dense structure beneath the South Pole Aitken Basin on the moon's far side has sparked significant scientific interest. This anomaly, detected through gravity mapping and radar data, is thought to weigh billions of tons, but its origin remains uncertain. One hypothesis suggests that the anomaly is the remains of the asteroid that created the basin. The impact could have embedded metallic fragments deep within the lunar crust. Another possibility is that the structure is composed of materials from the moon's mantle, brought to the surface during the collision. Alternatively, the anomaly might represent an unusually high concentration of oxides formed during the moon's early differentiation. Studying this structure could provide crucial insights into the processes that shape the moon's interior and the solar system's history. Theories about the moon's mysteries extend beyond its surface. They inform our understanding of planetary formation, magnetic field evolution, and the distribution of water and volatiles across the solar system. For example, insights gained from studying lunar water ice could be applied to other celestial bodies, such as Mars or Europa, where similar processes might occur. The moon's magnetic anomalies and swirls offer a natural laboratory for studying how localized magnetic fields interact with the solar wind, a phenomenon relevant to space weather research. Similarly, investigating the moon's seismic activity and subsurface structures helps refine models of planetary geology and tectonics. The moon's mysteries are a reminder of how much we still have to learn, even about our closest celestial neighbor. Each theory, whether about its formation, magnetic anomalies, or water ice, represents a step toward unlocking the secrets of the moon, and, by extension, the history of the solar system. As new missions venture to the lunar surface and advanced technologies provide more data, the answers to these enduring questions may finally come into focus. The moon, with all its mysteries, continues to inspire humanity to explore, question, and discover.